What's more frightening? An enemy you can see approaching, or one you know exists, but you have no idea where it is. Today, we're going to dive into the story of a real asteroid, a cosmic ghost that astronomers lost sight of. We will investigate the possibility that the silence from the National Aeronautics and Space Administration isn't due to a lack of information, but a calculated decision to prevent global panic. Humanity has a long and traumatic history with objects from the sky. We don't need to go back to the dinosaurs. Let's go to 1908 in Tunguska, Siberia. A mysterious explosion with the force of 1,000 Hiroshima bombs flattened over 1,200 square miles of forest. There was no crater. The conclusion? An asteroid or comet exploded in mid-air before it ever touched the ground. No one saw it coming. It was a lightning bolt from a clear sky. Fast forward to 2013 in Chelyabinsk, Russia. In the middle of the smartphone and internet age, an asteroid 65 feet in diameter entered our atmosphere completely undetected. The fireball was brighter than the sun. The shockwave shattered windows across the city and injured over 1,500 people. Where was our planetary defense shield? Why didn't anyone sound the alarm? The answer is simple and terrifying. It came from the direction of the sun, a blind spot in our detection systems. These events aren't just stories from the past. They are proofs of concept. They prove that despite all our technology, we are still vulnerable to a cosmic surprise. To understand why an asteroid can disappear and become an even greater threat, you need to know two concepts that astronomers rarely discuss with the public. The first is the observation arc. Think of it as the amount of time we spend taking a picture of a fast-moving car. If you only observe an asteroid for a few days, your observation arc is short. You have a vague idea of its speed and direction, but any future prediction will be wildly inaccurate. You need a long arc of months or years to chart its orbit with confidence. The second, and more frightening, is the Yarkovsky Effect. It sounds like science fiction, but it's real. An asteroid isn't just a cold rock. It spins. One side is heated by the sun, and as it rotates, that heat radiates into space, creating a tiny but constant thrust. Think of it as an almost imperceptible rocket engine. Over decades, this tiny push can shift an asteroid by thousands of miles from its predicted path. It's chaos theory at the tip of an astronomer's pencil. Now, put a short observation arc together with the unpredictable Yarkovsky effect. What do you have? A lost projectile. Imagine this scenario. At a forgotten observatory in Chile, a night scan algorithm flags a faint movement, an anomaly. Astronomers point the telescope. The data is sent to the Minor Planet Center. The object is cataloged as 2007 FT3. They observe it for exactly 1.4 nights. The observation arc is dangerously short. The first projections are messy, but a few of them, the most worrying ones, show a small but real possibility of an impact with Earth in a few decades. And then, the weather turns. Clouds cover the skies. By the time they can look again, the asteroid has moved to a part of the sky where it's impossible to see. It's gone. Lost. Years pass. 2007. FT3 becomes a footnote, until one day, a new, much more powerful space telescope detects something. Computers at the National Aeronautics and Space Administration analyze the data. The alarm sounds, not on the news, but on the secret terminals of the Planetary Defense Program. The spectral signature, the estimated size of 1,100 feet. It's him, 2007 FT3. But the orbit isn't what they expected. The Yarkovsky effect, working for decades in the dark, has subtly pushed it. The new calculations are run again, once, twice, 10 times. The result is always the same. The new trajectory is no longer a possibility, it's a certainty. The collision course is direct impact in 18 months. The news doesn't leak. How could it? What would happen if the world knew it had an expiration date? The financial collapse would be instant. Supply chains would grind to a halt. Laws would become suggestions. It would be the end of civilization before the impact even happened. A deafening silence is the only possible policy. 6 months before impact, the asteroid becomes visible to the naked eye. A new and sinister star that shouldn't be there. The official denial becomes unsustainable. The truth is revealed, but it's too late. There's no evacuation plan for 8 billion people. There is no ark. There is only the countdown and the watch of the sky, as the point of light grows larger and larger, night after night. Of course, the official position from the National Aeronautics and Space Administration on 2007 FT3 and other lost asteroids is one of absolute calm. They claim that, statistically, the probability of one of these objects being on an impact course is so infinitesimally small that it's not worth losing sleep over. They tell us their models are robust, and that if there were a real danger, they would know. However, this confidence ignores a fundamental flaw in the system. They themselves admit they have only mapped a fraction of all near-Earth objects. But the weakest point is the blind trust in their own models. The Yarkovsky Effect is notoriously difficult to calculate without knowing the asteroid's exact shape, composition, and rotation. Data that is impossible to get from an object you only saw for one night. To claim they know where it went isn't science, it's an educated guess. And history shows us that when it comes to the cosmos, guesses can have fatal consequences. But what if you need irrefutable proof that they not only can lose an asteroid, but that a policy of silence could be real? We don't need to look in leaked documents. We need to look at an event from 1972. It's the case of the Great Daylight Fireball. An asteroid the size of a bus entered Earth's atmosphere over the United States, was visible in broad daylight for 101 seconds, and then skipped off it, back into space. It arrived without warning and left without warning. Now, the crucial part. Declassified reports years later revealed the frantic conversations that took place inside the North American Aerospace Defense Command. At that moment, at the height of the Cold War, they didn't know what it was. A Soviet missile? A new weapon? The decision made in those minutes of panic could have triggered a third world war. And the public? They knew nothing about it until much, much later. This proves one thing: a precedent and a capability to keep high-risk celestial events secret to maintain stability absolutely exists. If they did it in 1972, why wouldn't they do it today? This brings us to a fascinating and dark theory, that the Planetary Defense Program at the National Aeronautics and Space Administration has two missions. The first, public, is to find and deflect threats. The second, secret and unstated, is to identify unavoidable impacts and activate a protocol of silence known as the ARC protocol. The theory suggests that in the face of a civilization-ending impact, widespread panic is the greatest enemy to the continuity of the species. The protocol would dictate that the information must be contained at all costs. While the world goes about its business, resources and key personnel would be quietly moved to deep bunkers and shelters, the modern-day ARCs. The goal wouldn't be to save everyone, which is impossible, but to ensure a core of civilization, knowledge, and genetic material survives to rebuild. I'm not claiming this is a real plan, but it raises a chilling ethical question. If you knew the world was going to end, would you tell everyone? In the end, the fear of an asteroid like 2007 FT3 isn't just about the rock itself. It's about our trust in the institutions that have sworn to protect us. It's about the possibility that, in our moment of greatest need, the truth would be the first casualty, sacrificed on the altar of order. The real impact wouldn't just be the crater on the Earth, but the crater in our trust. And now, I ask you, if you were in charge, and you knew with 100% certainty that a global impact was inevitable, what would be your decision? Would you reveal the truth and risk immediate chaos? Or would you keep the secret to give humanity a few last weeks of peace? Leave your difficult decision in the comments. If you enjoyed this trip into the hidden side of space exploration, don't forget to subscribe turn on notifications, and check out our video on what scientists aren't telling you about Earth's next impact winter. Thanks for watching, and I'll see you next time.